Hello everyone, welcome to this LeetCode daily coding where we are going to go through remove color pieces if both neighbors are the same color. So basically in this program you receive as input a string consisting of A and B, and then we are in a scenario where we are playing a game, and the rule of the game is okay, I can move a color only if both its neighbors are also color. And then we are two players and each of the player is attached to a given color. In this scenario, Alice is attached to color A and Bob is attached to color B. And you're supposed now to find out who is going to win the game. Someone loses the game if it is his turn and he is not able to perform a move. That means he's not able to remove a color. So if you find yourself in that scenario, you lose the game. Okay, so now given that, how are we going to solve it? Let me give you some examples so we can understand better where we are going. If we take this input, for instance, we have A, B, B. Now, Alice can start. Alice can remove this A because this A is neighbor by A and an A, right? So it is a valid move to remove this. Now, Bob can't remove anything because this B is not surrounded by B, so we can remove it. This B is not surrounded by B because we have an A here and B here, so we can remove this and we can remove this. So basically, Bob loses the game because he can't perform any move and it is his turn. So now, given those explanations, how are we going to solve it? What will be our approach of solving this? My approach will be as follows, right? So I will count the number of blocks of specific characters, and each block greater than 2 actually contain element that can be removed. So that will be the idea here, right? For instance, in this one, what I will do is I will say, okay, we have a block of 3. A block of 3, that means we can perform 3 minus 2. That means 1 valid move. So at least have 1 valid move. And then here, nothing. Here, nothing. And here, nothing. So we are going to end up with at least 1 valid move and Bob 0 valid move. And then we see, since Alice is the one starting, if the number of valid move of Alice is greater than the number of valid move of Bob, she's winning. Otherwise, she's losing. So let me give you an example so you understand better. Let's say I'm here, for instance. I have I will say, okay, initially Alice move is 0, Bob move is 0. Now we say this first tree is actually a couple that will give Alice move +1, right? This one will add +1 to Alice move. Now I have this one, which is actually a set of B, which is not actually adding point because it's less than 2. This one, we have this one also. Let me take different color so it makes better sense. This one is 2, so we can't remove any of them, so we leave them. This one we can't remove because it is only 1. This one is actually a set of 4, so we can remove those 2 elements. So those 2 elements can be removed. Now if those 2 elements can be removed, it adds +2 point here. And then this one, we have a set of 4 elements. That means these 2 can be removed. Oh, I made an error. This 2 was here. So this first 2, this 2 is for this one, and then this 2 is for this one. So basically, that will be the idea here. Count the block of the same colors, and for each block, compute the number of valid moves you can achieve from that block, and then add it to the total valid move of each of the player. And at the end, if the total move of Alice is greater than the total move of Bob, you return false. Why that condition? Because Alice is starting. So if neither Alice or Bob can perform any valid move, Alice will lose the game because she's the one starting. So what would the code look like? The code will be as follows. So I will have Alice move, Bob move. I will initialize 0. I will have last index, which is actually the index of the last color, right? So I will say, okay, instance here, the last index will be here. And then the idea is that when I will move, I will check if the color is still equal to the last index. That means, okay, we are in a block of the same color. At the moment that the color will not be equal to the last index, I will say, okay, we have ended up with the previous color, we should compute it and before moving. So we have the first character, which is actually the character attached to the last index. And then here we are looping from 0 to the color size. I'm going to equal to the color size because I really want to also handle the last case. You do agree with me that if LA is here and then you move till here, you will never find yourself with a different color, but you want to handle this. So you need to make sure that if you're at the end of the loop, you also handle the color that has been created before. So that is how I'm doing. I'm moving this way. I would say if I'm at the end, or if the color is different from the first color of the set we are searching, we are going to check, okay, if the first is equal to A, so the point are going to Alice. So the point is actually I minus the last index minus 2. But if the total element, let's say we are here, we move from here to here, the total element is actually 2. If you compute I minus LE minus 2, this will give you 0. You take mass of 0, 0, which is 0. Now for someone like this, if you compute the point, it will give you minus 1. But you don't want to give user minus 1 point. That is why you need to perform the max of 0 and this value. And then if it is not B, if it's not A, it's B that is going to take the point. And after performing this, you should say, okay, LA will take this index, and first will take color of LA. And at the end, you just return AM greater than BM. I do agree with you that in this scenario, if the I is actually equal to color of size, this is actually a little bit, this is out of range. But here we are not punished for that. So you can add an extra check if you want to make sure that you don't access element which is out of range. You can add an extra if here. That's up to you. But here in C++ is actually moving perfectly, no error. So this is my approach of solving this. I hope you do enjoy it. I will leave you a simulation after this so you understand better. See you on the next video. Ciao. Thanks for watching.